Welcome to part 2 of my build, and this is what we are going to build. Almost all of the parts comes from the Voron 2.4 or the Trident, and they have a wonderful website and a GitHub where you can find all files and documentations necessary. I still have to design and print some parts that are specific for this build, like for instance this front arm. It's a mirror pair on the front left and front right. This is a two-piece design, and I use a brass insert, or rather two brass inserts, to get this to print without using supports. We also need a custom part for the rear arm, and in this one it's a brass insert in the base plate and one in the arm. Otherwise it's about the same dimensions. We need a custom bracket for the tensioner, and this bracket is my design, but this tensioner and the idler, that's the original design from the Voron 2.4. Just have to print 3 pieces of those. It's pretty easy to print these parts, and I made them in 2 different components. One reason is that I want them to print without using supports, and the other one is that I want it to be possible to change the type of arm you use with this. It could be a different bed configuration. The bed could be further away from the front of the printer, and you may need some different configuration. So I'll provide this as a step file for the arm. I used Isonmate ASA for these black parts and ABS from Filament PM for these copper parts. You attach the arm to the base plate with M3 bolts. Initially I tried using 10mm bolts, but they were too long and rubbing against the belt, so I had to change that to 8mm later on. These parts are not symmetrical, so they will only fit on the correct side. And that's not by design, that's by chance, sort of. This is what the completed part looks like, and I think it's quite okay. We're now moving on to the tensioner, and this is the original part. The orange part is just from the Voron site, and you attach this 30mm M5 bolt inside this idler, and this just screws into plastic, so you don't need to tighten this too much. Adding the tensioner to this bracket couldn't be simpler. I'm just using a 25mm M3 bolt. And I'm also using a thumb wheel. These types of thumb wheels, we used to have them on our old printers when we did all the bed level adjustments manually. Maybe you have some in your old parts bin. We're now ready to attach these parts to the front rails, to the left and to the right, and to the rear. At this point it would be tempting to just mount the bracket for a tensioner, but you shouldn't do that. Do the front idlers first, because now you have access to them. When building these front idlers, we turn to the Voron Trident assembly guide and the AB drive and idler. And you can see the components with the AB drives and idlers. This is the front part of the idlers, and we will do this just as it's documented. There is absolutely no need to change anything on this part. And in fact, on the gantry I'm not going to do much at all that deviates from this standard gantry for the Trident. That makes this a lot easier, and it's documented much better than I could do. We now have easy access to the front idlers and can move the rails as well all the way, and that makes it easy to attach the tensioner bracket. The next step is to build these set drives. The only problem is I don't have any parts, or almost any parts. I do have these D shafts, 61mm long. In my previous build these were 60mm and round. I also have these 2 bearings, but only 2 pieces. I have a lot of old parts, and among them V-wheels like these. And these should contain a bearing. that is the same size as the one I want. Next step is just to get the bearing out of this wheel, and how difficult could that be? It was in fact quite difficult, and I damaged the bearing badly. I can't use this. I have to find something a little bit smarter than this. I'm sure there's a tool that could work for this, but I'm 3D printing, and I'm trying to 3D print a tool I can use for extracting these bearings. This is what I came up with. A very simple design with a 3D printed part, a washer and a bolt. I would then tighten it until the bearing got loose from the wheel. And it took some force. There you can hear it got loose from the wheel. I'm getting 2 bearings from each of these wheels. So I had to repeat this a lot of times to get everything I needed. Thankfully, 3 set drives is enough, but I still haven't got any gears. So I had to go to printables and look what I found there, and I found this is a 2-part design that I can glue together. I made some changes. I added a chamfer and modified it to fit with the shaft that I had. Had one side grind off, and I found another one, 20 teeth pulley. I did the same thing to that one. By now I have the parts I need for the build. They may be of questionable quality, but I'm going to try them out anyway. And I'm turning to the 2.4 assembly guide and will follow this just as it is. The assembly guide is very impressive. It's got a lot of detailed information you need when you do this build, and how to check that everything you built is in the correct position. This takes a lot of effort, and I'm amazed by how much time they put into this. If you follow this guide, I think it's going to be very difficult to make any serious mistakes. But of course I'm introducing some very dubious parts, so we'll see how that turns out in this build. Getting on with the build, I need a lot of heat set inserts for this build. And I'm getting these from CNC Kitchen. These are M3 by 5 by 4. That's the perfect size for this, and the holes are 4.7 millimeters. And I'm using a standard soldering iron with a special tip that matches these heatset inserts. All these parts are printed in Eisenmate ASA. And I then move on to the retainers. They also have a lot of heatset inserts. I think my soldering iron is at 260 or 270 degrees at this point. This is the drive unit with the printed gears, bearings, shims added. And it spins freely, just like it should. I could of course buy these gears in metal, but I was thinking I should trust some of the components I can print myself, and I'm going to try this out, and then we'll see. Before closing this part, I have to remember to attach these belts. They won't go in when I have completed this part. The next step is to add some 40mm bolts to attach the retainer to the rest of this drive housing. And I'm using proper gates belts on these. I had an extra set from my last build. I should have cleaned the surface on these prints, but I'm not going to bother with that now. The next step is to add these bottom plates, and I'm using a short 8mm M5 to hold this nut in place while I'm placing this on the drive unit. I will then remove this later. This plate is for attaching the feet, and I have printed some in TPU. This is printed in Fiberflex 40D. Next up is getting the steppers ready for set, and I'm checking the height of the pulley with a special tool. It's very convenient to do it this way. With that we can move on to attaching everything to the frame. And I'm starting off with a gear unit. Just need to get these two T-nuts into the correct position. You then simply attach them with two long bolts like this. Next up is attaching the stepper motor. I just need to get this in the right position. And the stepper motor slides in. This part of the build is really enjoyable because this is a very good design. You just attach the stepper motor loosely to the extrusion. Don't tighten it fully. Then you tension the belt with the arm, and then you can secure the stepper motor to the extrusion. That's it. I'm then adding the TPU 3D printed feet, and this is the center drive mounted onto the extrusion. I'm adding a corner part with the rubber feet in each of the rear corners, so we have rubber feet in all four corners of the printer. I'm ready to attach the belts for the first time, and these slide in without any problems. And I like this way of attaching the belt. It's easy to adjust and easy to replace the belt. When doing this, I discovered that there is a problem with this piece. It rubs against one of the bolts. The belt rubs against one of the bolts, and the belt is too far away from the extrusion. I have to redesign and reprint this part. I redesigned this part by making it 2 millimeters thinner and countersunk the one bolt that was interfering with the belt. The reprinted part worked fine, and I have the clearance for the belt and also the correct path for the belt. So that's fine. I did the same change on the other side, and that is also correct now. I have to wrap up this video. It's becoming a bit too long, but I also have to complete this rear attachment for the belt and check the rear belt path. Attaching the rear belt is even easier than the front ones because you have much better access. I then need to tension this belt and check the path, and this looks great. I hope to see you back in part 3. Bye for now.